Welcome back. Today we're going to talk about, or this time we're talking about section 3.1, part 2. We're continuing our discussion of functions, and in particular we have the function machine up here that we ended with last time. Now, what we were just talking about is that when you put something into a function, in particular an x, or something from the domain, you will get an output, and that will be something in the range, or a y value. That's how we're used to seeing it. Traditionally, we have the set x that goes in and is the domain, and the set y, which is the output. So what we're going to practice now is just really doing some examples with one particular function. Some of them we might be plugging in some letters. It might just be not. It won't just be numbers, and that's something we'll have to get used to. So let's take a look at that. So first off here, what we have are just a bunch of examples. I know they sort of look like these amoebas up here, but these are all functions, right? They all follow the rule that for each x, there is exactly one y. It's not a unique y necessarily, but there's exactly one y. So in the upper one up here, we see 1 is mapped to 1, and -1 is mapped to 1 also. That's something that happens in real life, right? It happens with this x squared function, right? So our domain is the x's, and the y's are the x squareds. One thing we notice here, our domain can be all real numbers for this function, but our range is only going to be positive things because x squared always makes things positive or 0, right? It's not going to be all non-negative numbers. If instead we go over to this guy right here, which is 1 over x, we're going to see some other interesting things happening. -2 is mapped to -2, right? Into -1/2, excuse me. -1 has a relation with -1, right? And 4 has a relation with 1/4. So there's some very interesting properties about 1 over x. What we see in this case, though, is that we should have a full domain, which means all real numbers, and a full range, which is all real numbers, except for one very important number. The one number that is not in our range would be something that would be bad that would happen over here. That's the case when x equals 0, right? If x equals 0, you cannot divide by 0. So that's the only bad thing. One way to think about domain and range is your range, you can assume that it's almost everything, right? Of course, in this case, it wasn't. It was all positive. It's almost everything, but then if you encounter something that's obviously bad, in this case, dividing by 0, then take that into account and remove it from your list of things in your range. Now look at these other two just very quickly. With square roots, we cannot divide by, or you can't take the square root of negative numbers. We can't, so that's something to be aware of. You can't take the square root of 0. Notice that. And for this one, this is actually a range is just one number. It's 3. While the domain could be anything, because whatever you plug into this function, it ends up being 3. So some examples of domain and range. Now let's actually calculate stuff. So here's one function, -3x squared plus 2x. We're going to do 8 different calculations on it. And some of them from the very simple of just plugging in a 3 in the x position to others where we plug in this whole long thing over here. So let's go through them. And I've sort of done it step by step for you already. So a lot of the work will just appear on here. So for A, we just plug in x equals 3 in the appropriate locations. Make sure you do PEMDAS. That is very, very important. But what we have here is -3 times 3 squared, right? Make sure you do it the right way, plus 2 times 3, and our answer ends up being -21. Now the reason is, of course, you have -3 times +9, right? So be aware of that. For B, now we can use the work we just did before, so we know that f of 3 equals -21, we just did that, and f of x is exactly what we have up there. So the end result, using our properties we've talked about before, or maybe talk about them at the end, is we just add these together and we get a nice quadratic. -3x squared plus 2x minus 21. Hooray for us. And now finally, C is when we're multiplying from the outside. So that means we have to, in effect, distribute this 3 through our f of x. If we distribute it through, we're going to get -9 times x squared plus 6 times x. And there we go. So you see in some cases you end up with a number for an answer, but if we plug in some other idea and some other things, like in this case we're really plugging in x for x, it's just staying the same. And we're multiplying everything by 3. We're creating a different version of this function, which we'll talk about in section 3.5, because multiplying by 3 does affect the function in some way. So we'll keep that in mind. Let's move on to D. So now we're going to say that instead of x, we're going to have x changed by negative x on the inside. What does that do? Well, it means keep the parentheses there, very important, that we have negative x squared. Well, that means negative x times negative x gives us a positive x. Over here we have 2 times negative x, that gives us a negative 2x, and there's our final answer. With e, we now have that minus sign on the outside, so it's the same as saying minus 1 times our f of x. Well, that just means we want to distribute like we did before. Our x squared is not affected. We just have negative times a negative, so we have a positive 3x and a minus 2x. So notice these two guys are not the same. So having f of negative x is not necessarily the same as negative f of x. It certainly is not in this case. Now we'll move on to f of 3x, which means we have to put a 3x wherever we had seen an x before. We'll plug this in. Make sure you do 3x, the whole thing squared. So that means we have 9x squared come out of that. Now we finish that off. We get negative 27x squared plus 6x. Okay, now let's move it on to the last two. F of x plus 3. Notice right here, x plus 3 squared is going to require us to do something. You might remember it. It's called FOILing. F-O-I-L, or first, outside, inside, last. We'll do that on this first x plus 3. And we just have to distribute the 2 to the x and to the 3 over there to get 2x plus 6 on that side. So we've done, now we did the FOIL by itself. I guess I did it by itself. And now we're going to move on and we distribute both of the things and we will combine terms to get our final answer. And finally, our last step. It may look really, really complicated, but if we break it down into parts, it's not so bad. Notice that this first one, f of x plus h, should look very similar to the g one that we just did before, x plus 3. Instead of having x plus 3, the 3 is now the h. So we still have to do our same things. We have to FOIL and distribute and combine terms. So we get this whole super long thing right here. But what's really nice about this is once we subtract f of x, and remember when we're subtracting, that means the minus sign is going through. That's the same as e right there, right? So we distribute that through and we end up with this right here. Negative 6hx minus 3h squared plus 2h. It may still look ugly to you, and in fact the final answer may look ugly to you, but it really isn't. Because we'll pull out the h's, and that's when you can cancel. Whoops, you can cancel this. So the h's go away, and you're just left with this. Now, I'll tell you right now, this is called a difference quotient, and you have just taken a derivative, in effect. Okay, this is the kind of thing you will do in a calculus or applied calculus course if you choose to take that in the future. So that's a very exciting thing. All right, so these are a bunch of operations. We plugged stuff in, we got answers out. Important facts about functions. I know that you can read these yourself, so I'm not going to belabor them. But really, what we talk about here is just talking about the domain, right? That's very important, and that you get an element of the range from plugging something in the domain. That we what is f, and this thing like the independent and the dependent variable, which is really just saying you plug something in and the thing you get out is completely dependent. So y is completely dependent on what you choose to plug into your function, because it's like a machine. It's basically preset, right? It knows when you plug something in that something's going to come out. And we'll finally end this section by just mentioning that you can add, subtract, multiply, and divide functions just like you add, subtract, multiply, and divide numbers, or do algebra with these things. So you have to be careful, though, that you don't divide by 0 on the bottom. Well, this is our first section. I'll be back with section 3.2 very soon.